Okay, I figured out how to get the part into the slicer and then into the 3D printer, and now what I'm doing is printing it in low quality to see what low quality means. I mean, they have specifications on what it means, but it's hard to put that into what a part will really look like. I gotta close the top because it's supposed to keep it right temperature in there. But this stuff is cool. So this part is like a gauge, allowing me to see, you know, when I print under these particular conditions, what I can expect the quality of the part to be. Probably next weekend I'll print the same thing at a much higher quality to see what I get, if there's any significant difference. But right now, even at low quality, it looks like it's more than sufficient for our needs, but we'll see when it's done. It's got 53 minutes to go. Okay, this is the part. It's still on the build plate. I've taken it out so you can watch me remove it and de-sprue it, I guess is the word, clean it up. So I'm going to zoom in so you can see it better. I hope I keep it centered. Okay, so one thing you'll notice is the printer first prints a thing around the outside. It's kind of like a, I'm not 100% sure, but that's what they do. Now, this smudgy stuff is glue. You have to put the glue on before you start printing, so when it starts printing, it actually adheres to the glass, and then you have to unstick it from the glass with a thingy like this. And this is the part. It's not so hard, I guess. Just make sure it's still in the camera there. Okay. So each one of these holes, let me get rid of this sprue on the outside here. Now you notice these little things here. Okay, these are little what they call supports, because what I have, in order to support the hole, the top side of the hole as it's putting stuff, you have to support the holes, otherwise when the printer goes over, the stuff, the melted plastic could fall down into the hole. So the slicer automatically builds these little supports in there, and they're designed just to just basically clip right off. And the idea is it's supposed to support the hole. And I don't really care if it's in the hole. I was just seeing how well it would make a hole that was going sideways to the way the print was going. So what I would do then, if I really wanted this hole to be open, I'd probably go in there with a drill. But you can see the top of the hole is supported and the hole is nice and round. Okay, the quality of the build for being low quality is actually not too bad. That's just more supports. Well, I'm not going to bother taking that off. I've just seen how the hole would work. Now the parts I am interested in is these holes here. This is an important piece right here, because this part is supposed to be 3/4 of an inch in diameter. The hole it's sitting in is supposed to be 10 thousandths wider. So in theory, hopefully this hasn't fused into the hole and I can just push it through. Okay, it fused in, so that was a bad mistake. Okay, so it needs, when you're doing stuff like that, it needs more clearance, I guess. All right, so what I was going to do is take this guy out and see how it fits in the other holes. What I should have done is print this separate, so it would have been a better gauge. So that was the mistake here. Unless, let me see if I can't just hit it real hard. Boy, I tell you, that is strong. And this is only 10% fill. I don't know if you were watching it was printing before, but in this area under here, it's actually they just put little tiny walls that are about 2 millimeters wide. So this whole thing is basically only 10% of this is actual plastic. And boy, is that strong. Holy crap. That's good. That's really going to work well. What I should do is get my micrometer, calipers, and see what the actual hole sizes are. I'm going to do that later. Next weekend, I'm going to print a high quality version of this because that's going to take about, I think, 3 hours. And I'll have this guy printed separately so I can stuff it into the holes and to see which one it fits. Because the reason why is when you want to put something, you want to make parts that fit into each other, you have to have clearances. And the purpose of this gauge is to determine, when you have two parts, how much clearance you have to get so you can see they will actually fit together nicely. Because as you know, summer break is coming. I only got 2 weeks to go. This weekend, next weekend, and then after the following weekend is when my 2 weeks start. So it's June 26th to July 13 or something like that. I forget the exact. It's 2 weeks. In 2 weeks, it starts 2 weeks, just the way it goes. And I'm ramping up so that I can get the railgun developed. And this is really, I'm glad I jumped into this because this is going to make life a lot easier. Because the railgun had some weird angles and stuff that I was trying to figure out how I'm going to machine. And the only thing I could machine in my garage are things out of either plastic or wood. And I was trying to figure out how to make the weird angles that it needs. With this thing, I could just, it's easy to make the parts. And the Fusion 360 is a great CAD tool. And the Dremel, for pretty much, this is the second thing I ever print. Oh, let me get you the other thing from the other day. This is the widget that I printed before. And this came out really good. This is the first thing I ever printed in my life. That's the second thing I ever printed in my life. And I'll tell you, it's been a good experience. Everything's worked right, pretty much as expected. I'm pretty impressed. I think this is a good investment. And honestly, I think this is the way of the future. Anyway, thank you very much.